Hi everyone, welcome to our first lesson in our crash course about chemical reactions. That's right, today it's explosions, explosions and more explosions. That's right, because it's combustion reactions time. What is a combustion reaction though? So, a combustion reaction occurs thanks to this little fella over here. That thing you breathe in every day. Oxygen. So when we see all these films and TV shows where there's explosions and burning houses and all that sort of stuff, it's all because of this little fella here, oxygen. Come down to our triangle over here and have a look. So these are the three things here that we need to make a fire, alright? This is our fire in the middle. So what we do know is that, as I just said, we need oxygen. So to make a fire, we need oxygen. Right, so we know that we need oxygen, but there are two other things that we need to make a fire. Well, think about fire in general. Why do we go near a fire on a cold night? Or why do we light a fire and sit around it? That's right, because of heat. Because we need heat. So obviously, if you want to get a fire, it's going to have to be hot, right? So heat is another one. Now, think about that third thing. What could it possibly be? Think about when you watch all those movies and TV shows when they're trying to burn up hospitals in the dark night and blow up anything else in any other show. What do they usually use? What's something that's really easy to just blow up? That's right, fuel. So generally, you know, if you want to blow something up, just chuck a bit of gasoline or kerosene down, light a match and off you go. So fuel's the third thing that you need to make a fire. Let's have a look at our campfire here. So here we have our wood, right? It's not burning yet. So think about how can a campfire actually be a chemical reaction? You were just burning up wood, right? Well actually, it's a combustion reaction. Now I'll show you why. So our wood here, we remember our triangle here? So our triangle has to apply to the campfire here because it's a combustion reaction. So we know that we need a fuel source, an oxygen source, and a heat source. Well, our oxygen source is obviously going to be the air that's around anyway, right? We don't have campfires in space. We have them outdoors on beautiful country lands in the fresh open air. And now that's our oxygen, right? So we know that O2 right there, okay? But what's our fuel source? Generally, we don't really just douse a bunch of gasoline onto a bunch of wood, right? So the funny thing is that the wood here is actually the fuel. So we know that wood is one of the things that's reacting. And we also know that oxygen is going to be a reactant as well because oxygen needs to occur with the wood. But we can't just have wood and oxygen. We can't just put wood out into the open air and then expect it to burn, right? Which leads us to our third thing, heat. So what's our heat source? Well, think about it, right? Generally, our heat source here is going to be, well, a match, right? So if we have wood and oxygen, and let's put a match here as well, that's our heat source. Or well, if we just put heat, right? So let's go heat. We know that we're going to get carbon dioxide. We're also going to get water vapor. So we'll have H2O, but it's going to be a gas, okay? And then we're also going to end up with a bit of ash. Obviously, the charcoal, that sort of stuff, right? So there you go. So that's our combustion reaction right there. We have a fuel source, we have our oxygen source, we have heat that sort of acts like a catalyst or something that really makes the fire occur, okay? And then these obviously are products of our campfire at this stage, okay? So now you can see we've got all these things, and now look at the fire. It's starting to go, right? The fire's starting to burn. Alright, so there you go. We now have a campfire, okay? Perfect. Perfect for roasting some marshmallows. Alright, so let's have a look at that. So let's break it down even further now. So we knew that we needed a fuel source. We knew that we needed an oxygen source, which is generally the air. And we knew that we needed a heat source. So basically what we can discover, or what we know now, or can identify, is that if you have a fuel and you combine that with oxygen, then what you're going to get is always going to be carbon dioxide and water. Those are always going to be the products of a combustion reaction. Alright, so now, as I said, we're going to look at our properties of combustion reactions. Now we know have a think about combustion reactions, everything we've spoken about so far. Come back over here. Let's look at our massive explosion here, right? When we have explosions, you're not just going to get up and walk away from one, are you? If someone blows something up, you're not really going to be able to just waltz out of there and be A-okay, are you? Because the truth is, explosions happen pretty quickly, and if you're in the middle of one, well, sorry to say, but you're pretty much stuffed. Alrighty? So we know that explosions or combustion reactions in general, they're pretty quick, alright? Let's have a look at our fire as well. What else are they? Let's go straight to explosions and campfires. What are they? They're pretty hot, right? When you think about fire, you think heat, as I said before. So remember, heat. They're going to be hot, alright? Now we have another word for hot when it's a chemical reaction. So in terms of chemical reactions and their properties and stuff, when we actually think about something that exerts heat or creates heat, that's known as an exothermic reaction. If we think of the word exo and think about exit, it's almost like heat's trying to leave the reaction, right? So heat's getting out. Okay? So we know that in a combustion reaction, explosions, campfires, whatever you want, it's going to be pretty hot. So there's heat getting away and leaving. Okay? So it's an exothermic reaction. Alright, now the last thing we're going to look at here for our properties is what else? So when we have a combustion reaction, obviously heat's a byproduct, but there's something else. Something that mixes with heat. Alright? Sometimes this is the reason why campfires don't get started easily. Because fire is sharing heat with what other thing? Think about fire. That's right, it's the light. So sometimes the fire doesn't get started, doesn't get hot, because it's having to share it with light. Sometimes we see all the light and not much heat. So if there's too much light and not enough heat, then sometimes your fire won't get started very easily, alright? So it's light. So these are some of the properties of a combustion reaction. So let's go back to our campfire now. I want you to go away and have a real think about some of the combustion reactions that happen every day. There are so many out there, so many that happen inside your house and outside your house that would happen every day and you wouldn't even realise. Go have a think about that, have a look at this equation and see if you can figure some stuff out. And make sure to answer the questions below. Thank you.